Hi, welcome. So today we're going to be having a go at Dear ImGui, Dear ImGui, or Immediate Mode GUI. And yeah, this is in C++. And yeah, I like to usually just use plain C, but today we're going to have a go at this library because it's a very, very cool library. Um, Dear ImGui. Now, if you just have a look down on this repo, we've got these couple of little cool widgets. And there's a lot of UI components that you can create very cool GUIs with. So if you just keep going down, there's like, yeah, some very cool examples here of some pretty complicated sort of game engine sort of UIs that people have created. So yeah, so the goal of today is we're going to try and set up these couple of examples here and have them running. Now, like I said, I like to do stuff in C because yeah, I just find it a little bit simpler and it's a pretty cool language. So what we're going to try and do is compile this as C++, but then we're going to write all our stuff in C. So even though this is in C++, there is another project here called CMI that gives us bindings for C. So it's like a little wrapper that we can use to call all these functions from C. And yeah, I mean, feel free, you could still follow along with this and just use the C++ version, but I'm going to use the C ImGui version. And what we're going to actually use as our backend renderer is Sokol. So I've done another stream on setting up Sokol. So yeah, if you want to know a bit more information about that, but we will be setting up the basics of Sokol. So yeah, let's get into it. So Sokol, I sort of like to just follow this style where we've just got these simple STB style libraries where we could just include the libraries and just make our life easier than trying to have all these complicated build systems. Um, and we're going to try CMake today because we have used make, just plain make files in the past, but given this is going to be a little bit more complicated, CMake's pretty much become the industry standard, especially for C++, and I think this is going to make our build a little bit simpler. So we're going to use CMake. All right, so you can see here on Sokol, so we've got this, yeah, the core libraries. So we're going to use this one, Sokol GFX. We'll use the Sokol app, and I think that's probably all we'll use there. And then also these utility libraries, we've got the Sokol ImGui. Yep, this one. So we're going to use this one. Yeah, so let's get into it. So first up, all right, so yeah, I've got a blank directory here. Let's zoom in a little bit. There's nothing in this directory, so we'll just go straight into it and let's just start coding. So first thing, I'm going to make a makefile just because even though I'm going to use CMake, I'm actually going to also use a makefile. So we'll add a makefile, we'll add a source.main, and we'll add a CMake lists.txt file. So this is our CMake file here. So maybe let's just start off a real simple C file, standard.io.h. Okay, so we'll just start off with a real simple hello world, print hello world to the output, and we are done. So let's go to CMake. Right, so CMake, to be honest, don't know a lot about CMake. I'm still just learning it, so just bear with me while we sort of, yeah, let's try and create the minimum CMake file that we can create. So CMake always requires you to specify a version. It's sort of like the minimum version. I'm just going to say 3.15. I don't really know what version I should be using here, but this is the version that I was using and it seemed to be fine. So you do have to have CMake installed. So if you type CMake version, uh, yeah, I'm on version 4. So this is pre-installed, but yeah, whatever platform you're on, you can install CMake. So we're going to create a project here, and our project's going to be called Sokol ImGui. Does that sound? Maybe we'll call it ImGui demo. That sounds a bit more fun. And we're going to write in C, and we're also going to do C++. Um, so I'm just going to leave it at C for now, and we'll add the C++ in later as we need it. And we're going to include some directories. Include this current directory. And I think that's pretty much it. And then we can actually just add an executable. And our executable was just going to be called ImGui demo. And we're going to use a file from the source main.c. And that's probably enough, I think, to get started. We actually probably don't even need this line here, to be honest. So let's comment that out for now and see if we can compile it with the absolute minimum. So with CMake, basically you create a build folder. Okay. You then change into that build folder, and you write CMake back on the previous directory where the CMake list file is, and we get an error. Okay, unknown command CMake minimum requirement. Yeah, I've definitely spelled that wrong, haven't I? Required. There we go. Even my syntax highlighter picked that up. Okay, that seemed to work. So what that actually does, it creates all these files here, and it actually created a make file. So by default, especially on this Mac, it's generating a make file as a build system. So CMake actually just generates a make file or a makes build file to build your program. So all CMake's actually done here is generated this make file, which we could have typed that out, and we have in the past, but I mean, not one as complicated as this, but we could certainly write our own make file. But there's all this big long make file that's just now automatically generated. Actually, doesn't actually look too bad, the simple version, to be honest. But so yeah, from there we can just like hit make and make. And now we've got this ImGui executable, ImGui demo, and hello world. Okay, cool. So yeah, let's what we're going to do now, I usually create this depth folder where I put all my dependencies. So in here, I've actually got we actually want to use sort of import all these files. So what I'd usually do is come in here and find the files that I want. So I want this Sokol app and Sokol GFX one as a dependency. So, but what I've actually done before, I've actually pre-created some of these as like a make script. So what I'm going to do is just grab them all in my make script. So what I'm actually doing here, so this is probably a little bit confusing, but we've got a build folder. This is my actual building my program. And I'm actually going to use make files here just as like a utility script runner. It's just going to run a heap of commands for me. So I've just copied this from a previous repo because I've done this before. So I've just got a make task here to do update Sokol. And what it's going to do is go and fetch that file from GitHub. So you can see here, this is the repo, but basically this is a raw file, and to find that URL, you just come into Sokol repo, and so for example app, you click on this app here, and then GitHub gives you this raw version, and you can click on that, and that will take you to this URL, and that's the raw URL that you can just download directly. So I'm just using wget. You can use curl, doesn't really matter, just something to download the file, and it's going to put it into this steps folder. So we're going to get the Sokol app. I don't want audio. Glues. So this is the graphics library. The glue basically connects sort of the app and the graphics together. I don't need time. We might just keep the logger. And yeah, this is the other one that we were sort of looking at before, the utility one for in Sokol ImGui. So that's going to be our Sokol ImGui bindings. So if we're going back to Sokol, you can see here that there is a utility folder, And in here, there's like, yeah, different, um, you can sort of bind Sokol to different libraries, but we're using this Sokol ImGui one. Okay, so yeah, all right, so now, yeah, I can just run this make task now, and we should just end up with, so I'm in the build folder, so I've just got to go back to make and make update. Um, no rule. Why have I got no rule? Did I not save that? Oh, I mustn't have saved my make file. Okay, so now we've got that all downloaded, and you can see here we've got all these files directly in our repo already. Okay, cool. And the other ones that I want to actually get, I just want to show you is the, what I explained before was the CMI GUI. So we've got this one here, CMI GUI. So this is the C bindings to ImGui. And in here, there's a master branch, but there's also this docking branch. So in this docking branch, it's ImGui's got this like nice docking feature where you can like dock windows and stuff, and it's actually really cool. So I'm going to use that version. It's the same as on the ImGui. There's a branch. I don't know why it hasn't gone into the master branch yet, but there's this docking branch. So we're going to use that one, that version of it. And in here, so when I go to that branch, the docking branch, what I really need here is these like CMI GUI files here, the C++ ones, the header files, and a couple of these C++ files. And then in here, there's actually a link to the, it's a submodule of Git that there's a link to the ImGui. But if you actually look at this, this is like on a particular commit hash. So this is the commit hash that these C bindings work for. So we've got to make sure that we use this commit hash here. So when we're going to download ImGui, you'd have to make sure that you go and find, basically in ImGui, we're going to just basically download all these files here. And you just click into each one of these and hit the raw, and you can see that that's on that exact commit hash, not off the sort of the master branch. So yeah, what I've done, so to save a bit of time, I've actually sort of pre-done all that because yeah, there's a bit of sort of time in trying to get all those URLs correct. And I mean, you can just download them once and be done with it, and just put them in your repo. But I like to just sort of script it up, make it a script that I can just like reproduce, and then if I want to do an update, I can just run that script again and sort of update the sort of dependencies, I guess. But I'm in control of when that update happens, so I can just sort of update at any point. So you can see here, I've got update CMI GUI. So this will download all those CMI GUI files. So we've got a config file, C++, and a header file. And you can see here the branch. So the main thing, see these ones are on the master branch, whereas this one's on the docking branch over here. And then the ImGui is actually on this commit hash. So that will give me all the files that I need. And if I run this one, this should also run this one. So if I run update CMI GUI, update CMI GUI, and maybe I didn't save that, I don't know. No such file or directory. That is a little bit strange. Let's click that link to see where it takes us. Oh, let's just run it manually. Oh, okay, yeah. So what it's actually complaining about, my bad, is that I'm trying to save it to this steps folder, but actually in a folder CMI GUI, ImGui. So I'm sort of trying to keep the same folder structure as what they had in Git. And yeah, you've actually got to make those folders yourself. I could put that as part of this script, but I'm just going to manually make those folders. So I only ever want to do it once. Okay, so now I've got that folder structure. Let's just run this again and hopefully we get, yeah, some better results. Here we go. So it's now downloading all those files for it. Okay, and here we go. So you can see here we've got all the files we need. I think this is all we need. And you can, I mean, just to make this simpler, if you want to do an update in the future, you can just write update deps, dependencies, I call it deps. And you could just sort of look up Sokol and update ImGui. All right, and yeah, so let's yeah, so we've got this CMI GUI here, and we've got this sort of like our C++ files, our um, header files. So this is the set. These are like the bindings. So you can, if you actually look at this file, you can see it's like a heaps of struct definitions, sort of all the C definitions. I think these are all auto-generated from the original, and you can see here, yeah, these are like these are the actual bindings. So you can see it sort of like creates a C wrapper around every function. So this one here is show about window, and it's just got this IG prefix, ImGui prefix, IG, and that actually underlying that calls the C++ version of that. So basically just converts C to C++. But I mean, if you're just doing this in straight C++, you would just use the ImGui library. So yeah, and the good thing about this the Sokol ImGui library, if you read this header file, this is basically the bindings between Sokol and ImGui. It says that you can use either. So here, the implementation can be compiled as either C++ or C. So when it's compiled as C, it uses Sokol imgui.h will directly call into the imgui API. So it'll essentially directly call this imgui header file. But if you're using the C version, it'll call this C imgui. So very nice library. The C Sokol imgui is very flexible and very nice. So yeah, let's get into it. So Sokol, yeah, so the first thing we just need to do is basically let's create a window and see if we can get this app working. So we actually, when you create a Sokol, you don't use the main function, you actually use the Sokol app main function. So we create a description and it's called Sokol main. And instead of taking a void, it should just take arguments and argc and argv, which is sort of the standard. So yeah, that's what we need to do. So before we actually do that, we actually need to import these files into our build system. So we should be able to say Sokol app.h. Oh, right. Yeah. So we get some errors here. So what we actually need to do here is we need to include this into our build system. So we go back to our CMake. You can see here this include directories. I'll include the current directory. I don't know if you need to do that or not, but we actually want to include the dependencies directory, right? So what that is like, because that's where all our files are stored. So we just want to include deps, and we actually want to include imgui. So that'll sort of include all this as well. Um, all right. Oh, and so yeah, so normally what we're going to do is define Sokol implementation somewhere. So what I'm going to do, I'm actually going to do that here. So I'm going to create a deps.c file and I'm going to include all the Sokol files here. So yeah, as you can see here, we need to define this Sokol implementation. So I'll define that here. And then from there, I can just include all my Sokol files. Sokol app, Sokol GFX, the Sokol glue file, and we'll include the log file. H. Okay, so even though that's complaining, I think we can now add that to here. And we should be able to now build that. So we go back to our build and we just run make. and we get an error, which is probably expected, I guess. So we actually need to return this app description. Okay, and yeah, let's just include a blank one for now. I mean, that might work, sort of. Okay, that's cool. That's starting to work. So yeah, what do we need to do here? We really probably just need to get this here to be compiling. So if you see my other video on Sokol, we basically need to add sort of a heap of like frameworks and different compile flags to actually get Sokol to compile. And I went into a lot of detail in the other video, but you can see here we sort of need to define these headers depending on which backend you're using, whether you're using GL Core, Metal, DirectX, or you're using like Web GPU. So there's sort of different options that you need to sort of specify. And when you're compiling on like Mac, which I'm compiling Mac, you need to sort of include these backends such as Foundation, Cocoa, and Quartz. So once again, I'm just going to steal a little bit of code. I don't like to do this too much, but it's just going to save us a little bit of time. And I will include a link to this in the notes, but we'll commit this to Git. So this is some code that yeah, I've sort of developed. And basically here, it's just sort of determining the platform. So if we're on Apple, which we are, and like if we were just doing this for just the platform you're on, you don't necessarily have to do this cross-platform thing, but we're trying to make this a cross-platform app. And one of the benefits of using CMake is that we can, it makes running cross-platform a bit easier. So we can say if we're on Apple, we're going to set this backend flag, and we're going to set a define variable. So we're going to define so-called metal, which is kind of, if you look in the app description up here, it's sort of doing the same thing. So you can actually use this define in the code like this. So you can say define and then the define variable, or you can actually just pass it as a flag to the compiler, which is in our case is what we're going to do. So we're actually going to pass that dash D is the define, and then the define variable name. So you can always pass a define into the compiler through a dash D. And then we're going to set some platform libraries. So as I said, we need to include Cocoa, Quartz, Metal, and Metal Kit. And the other thing, because we're on Mac, everything's basically written in Objective-C. And as you can see here, we're getting all these errors basically because these are objective. Some of these are objectives. Whenever you say NS, which is next step, which is the operating system, the original Unix operating system that Mac OS was written on. This is basically Objective-C code. So we're getting these Objective-C errors because we're not compiling with Objective-C. So we basically just say we want to compile with Objective-C. And yeah, if you're on Windows, these are sort of the Windows flags. I just got this off somewhere else. I think I got it out of a make file and converted it to a CMake file. So and same with Linux. This is just using the OpenGL core and just passing OpenGL library, mass library, pthread, and DL library. So I haven't tested this on Mac or Windows. So yeah, let me know if that works if you're on those platforms. So yeah, we've added them, and then we basically just need to sort of tell we need to sort of add those definitions. So there's an add definition, and we've got this backend variable here. So we basically just whatever our backend variable is, which we're setting there, we just need to set that as a definition. And what else do we have to do? And then we just, yeah, we need to target these. We sort of need to link to these libraries. So our app name is, our executable name is ImGui demo. and we now want to link to this see, we've basically just created a variable here. So we've created two variables. Um, is the backend variable, which we add as our definitions, and we add a platform libs. So we're just going to target these link libraries down here. So like if I was just on Mac, I could just sort of come in and just like, if I only wanted to compile this for Mac, oops, I could just come in here and sort of grab that string and just add that in there, hard code that in there like that. But then that's obviously not very sort of cross-platform friendly. So instead we sort of create these variables and then set the variable at the end. So yeah, let's set this variable called platform libs. Um, I think that's about it. So let's just so basically yeah. So I mean we've just got it's a relative straightforward CMake file. Set the minimum version, create a project, include some directories, and set some custom um, variables depending on the platform, and then we add the definitions. That doesn't look right, does it? Because I'm getting a yeah, I think this is definitions with an S. That looks better. Different color. So add the definitions that we specified here, and then we set the platform libs to link to those libraries, and we're creating this executable from these two files. So I only want to create it from these C files. So let's just run it and see what happens. Okay. So that cannot link libraries. So maybe I've using my most of my issues are always spelling issues. That looks pretty good. Target link libraries. Yeah, I don't know. That seems pretty good. Um, yeah, I don't know. I mean, I can. So the good thing about CMake is that you end up sort of putting all your build artifacts in this build folder, and it doesn't have to be build folder. You can really put them anywhere, but I can just like remove this build folder, and I can just sort of recreate it. I don't know if this is going to actually fix my problem, but um, let's just see. Yeah, I think there's a CMake regenerate. You can regenerate that rather than actually doing what I just did, but I forget the exact command. Um, not built for this project, yeah. All right, I'm going to have a short break and I'll keep debugging this and see if I can figure out what I've done wrong. So, all right, we'll catch you shortly. Okay, I've figured out what it was. So it's just that I've got this comma here. So I'm used to sort of programming languages that have commas between arguments, but yeah, in CMake it's just spaces. So it's a sort of funny language, CMake, but it is what it is. And like yeah, like I said, I'm just sort of learning it. So anyway, I think this is. I'm hoping that will work. Okay, so that's now worked, and we can now run make on this, and hopefully we get yeah we've got an executable. Okay, cool. So I don't know if this will run, but let's just see what happens. Okay, it actually ran. And we've got a window. So yeah, there you go. So we've set up Sokol very quickly using CMake, and we've got some yeah, SAMI GUIs ready to go. So all right, I'll see you in the next video.